Can everyone hear me? 100,000 people here. Just kidding. All right, cool. All right, so welcome you guys for coming to my talk about refactoring CSS bloat. If you want to follow along or check out the slides later, here's the link, bit.ly/CSS bloat. Cool, so I was introduced previously, but basically I am a front-end engineering manager at GitLab. I live in Austin, Texas, and my Twitter handle is ClemMakesApps. So if you have any questions, you want to follow up, see what we're doing at GitLab, feel free to message me. And if you've never been to Austin, this is one of the nicer pictures of Austin and some of the cool things you can do, outdoor activities there. So for you guys who may not know about GitLab, GitLab, if you kind of have to summarize it, is a single application for the DevOps lifecycle. So it's the idea of having one single tool to kind of do your development process and not have to switch between contexts of different tools. So it's very nice because you have one setup versus having all these things you have to integrate. And with that, I also want to mention that we are hiring. I want to thank GitLab for sponsoring me to come here and speak. And if you guys didn't notice yesterday in the news, we recently announced our Series D funding. We raised $100 million at a 1.1 billion post money valuation, so we're now a unicorn. So if you want to join a unicorn, we have lots of jobs, including my team. So if you're doing front end and you want to join that, cool. So with that, let's start off with defining what is CSS bloat. So CSS bloat can be defined in different ways, but the way I explain it is kind of code that is out of control. It becomes difficult to maintain to a point where it's starting to impact performance. It's a lot like a sinking ship. You don't really realize it's sinking until it's fully sunk. And so hence the GIF. So throughout this talk, I'm going to explain a little bit about GitLab's approach and how we've gotten CSS bloat because that's more relevant to my context. So hopefully you guys can learn from our mistakes and how to get out of it. So in order to do that, we have to first examine our history, examine what led to our sinking ship today. So GitLab used to have a really ugly logo with that fox over there. Thankfully, we don't have that anymore, so your stickers look nicer. But you might still see it online from time to time. And GitLab was really started off as an open source project, wanted to do just source control, kind of a GitHub alternative. But as we've evolved over the years, we've kind of added more things and kind of developed a whole new product in itself. So similar to the bottom part, we're trying to do more of a iterative approach, more minimum viable change. So we kind of started off as a skateboard and now we're on our way to a car, as opposed to building a wheel at a time. So whenever we go this route, it's really hard to build like scalable tools when you're building a skateboard because the skateboard mechanics is very different from a car mechanics. Certain parts will carry over, but with the iterative approach, it is quite common to build up technical debt like CSS bloat along the way because you're just wanting to build a product that people use and not necessarily want to build something that will scale but no one uses. So GitLab originally was a classic Ruby on Rails app. We have jQuery that does the DOM manipulation. We have Haml for templating the HTML, and then we have Ruby on Rails on the back end. So fairly classic Ruby on Rails. During the past few years, we've made tremendous improvements to GitLab's front end specifically. Specifically, we removed turbolinks. So if you're not familiar with Ruby on Rails turbolinks is a Rails gem, so a dependency that injects and evaluates JavaScript on each page. So the reason you want turbolinks is so that as you change pages, you're not reloading the whole DOM, fetching the whole HTML page. You're just changing the things that are actually meant to change. So like your navigation stays the same. But with that came a lot of different challenges from a front-end perspective because you have to be careful of how you handle your event listeners, whether you're turning them off or adding them. So a lot of weird bugs came from that, and so we kind of removed that and moved away from that to kind of separate front-end from back-end. We also converted CoffeeScript to ES6. ES6 has a lot of things that CoffeeScript was offering at that time and also increased our wide of contributions from the community as well because more people know ES6 than CoffeeScript, including me. And then we started using NPM for managing our dependencies. Previously, we were using more of the gem files from Rails, and we started using Webpack, and that really started to boost our productivity because Webpack is now handling most of the assets versus Rails trying to do their magic that I don't understand. And then we also introduced Vue.js, which you may have read about online as well. So Vue.js was kind of our alternative for high interactive UI. So with jQuery, high interactive UI is possible, but it's very hard to maintain. It's harder to abstract. It's easier to build debt. And so that's kind of how we moved towards Vue.js as our framework of choice. So you might be asking, that was a long list of cool things, but what about the CSS? Well, this is kind of what happened to the CSS. So this is a graph of our Sass file size over time. Even though our releases aren't exactly like the same time period, so for example, 8 is probably a lot longer than 9 and so forth, you can still see a general upward climbing slope of our CSS over time. So this is not great because although we've added more functionality to GitLab, we added CI and all these other things, the UI should be pretty consistent. You shouldn't be seeing this linear growth of Sass files as you add more pages. That doesn't make any sense. That's a good indicator that something is wrong and there's a lot of bloat. And this also impacts performance because now your clients are downloading more CSS to load on their browser than before every time there's a new release. So this is not great. And then in addition, our lines of CSS source code is also increasing over time. So this is hard because this means that there's going to be more code complexity. There's more cascading styles that you have to navigate, which also makes it hard to maintain because you have to start debugging. Maybe you do important on your attribute, and then when you want to change it in the future, then you have to kind of unwrangle that mess, and then that's just a downward spiral of pain. So that's kind of where we're at. And here's an example. One of the cool things about GitLab is that our code is open, including our Enterprise Edition, even though it's proprietary to run. The code is public. So even though we're not proud of this code, we want to show you that this is kind of what it looks like. We have 5-level deep selector. It's not very maintainable. If you wanted to change the paragraph tag to do display block for some reason in a certain situation, here you're going to have to do the important attribute or write a 5-level deep selector to override it. So not great. In addition, we also have a really strange way of setting up our CSS. We have, if you look at the left side, there's the framework folder. So we have like framework, kind of like more component style Sass files. And then we also have page specific, which isn't great either because let's say you add a new page, the admin page, you have some new UI there. When you add another page, you're not really going to cross-reference your old pages to see what you can extract. You might if you're a good citizen, but most people wouldn't even worry about it, especially when you get to our level of lots of pages. So this was another contributing factor to our current situation. And all of that really led to inconsistencies. So here is an actual screenshot from today with the drop-downs. If you notice the drop-down, the caret is actually a little bit off. They're not the same for the text and the icon when they should be consistent. So the way we've been writing CSS, a lot of it was just customizing for each UI element at a time rather than making it more reusable. And so you can start seeing how this impacts the user in addition to just load times of big CSS files. So overall, contributing factors to the CSS bloat is primarily not prioritizing the debt earlier on. Kind of like a sinking ship, it's hard to know when you're sinking. And it's also difficult to maintain without a set paradigm. So a few tips I wanted to leave in this page was kind of some of the things that we did to kind of make some quick wins on our CSS, even though we know that we have a lot of bloat. So one of the things that you can do is start adding gzip and loading your CSS using a CDN. So that decreases the load time, decreases the size of it, and makes it easier for browsers to load your CSS. It makes it faster, and it takes like very little work. And then the other thing is you always want to minify your production CSS, which you should already be doing that, but in case you haven't, you should do that. So overall, I would say the biggest cost of CSS debt is maintainability. So in addition to all the inconsistencies, I would say maintainability is what really gets affected. So I don't know if you guys have read about CSS blocks that was introduced by LinkedIn earlier this year, but this is kind of a quote that was in their blog post that I thought was really, really cool. It says, selective performance is not something to optimize for, selective performance is irrelevant, and the price we pay for optimizing for selective performance is indeed terrible, and we micromanage our work for gains that aren't even noticeable. So that is something that's really important to think about when you're trying to get out of CSS bloat. You want to figure out where the core problems are that you can work on that will give you the most gains, because there's a lot of rabbit trails that you can follow to make improvements to your CSS. So what are some strategies for organizing our CSS? That seems like a very important topic if you want to get out of CSS bloat. So one of the strategies is object-oriented CSS, and this is fairly popular in the community. It's the idea of separating your structure, your containers from your skin and content. So it's very simple. There's just two main categories for your CSS. The structure would be defining more of the invisible features such as margin and padding, how are you going to lay out, and then the skin is more of the visible features, so like the color, the font size, and so forth. So if we were to go through our previous example that we weren't very proud of and convert it to object-oriented CSS, this is potentially what it would look like. So we have our structure on the top, our skin at the bottom. Structure is kind of setting the clear and display inline, more of the background, behind the scenes stuff, and then the skin is doing more stuff that you see. So with that, object-oriented CSS has its own trade-offs. The advantages is that it's very clear. There's only two buckets where things can belong, so it's easier to see what should belong in what. And it also follows similar paradigms as object-oriented programming, which for some of us might be actually a bonus, because that's where we came from. The disadvantages is that it does increase the number of classes that's added to elements. So in the past, if you were doing your CSS, you can just apply one class to do all the things. Now you have to do the structure and the skin together, so you're technically adding more to your DOM. It's kind of negligible depending on your use case, but still something to think about as well. And another disadvantage is that it couples your content with your presentation. And so some component libraries, this is kind of what they're trying to achieve. They want that tight coupling, but in certain situations, this may be a disadvantage because you're trying to add things together. And so if you want to learn more about this way of organizing your CSS, I also have a link here about object-oriented CSS. So the other potential way you might want to go about organizing your CSS is using this way called SMACS, which stands for Scalable and Modular Architecture for CSS. So this kind of takes on a whole new level on top of object-oriented CSS. Instead of having two main buckets, categories for your CSS, we're adding 5. We're having 5 categories of base, layout, module, state, and theme. So what does this all mean? So base is kind of creating your default values, so similar to what you would do like normalize or reset. We have the layout, which is similar to what we were talking about in object-oriented CSS, setting up the structure, and then there's the module, which is kind of separating the concerns, and then there's the state that does the looks across certain states. So for example, if there's a focus state, that's kind of where you put it, and then there's the theme, which is similar to the skin from the previous example. So if we were to convert our code into SMACS, this is potentially what it would look like as an example. So base, we would set the margin to 0, the padding to 0, the module is setting more of the specific things to those CSS classes, the note, entry, and message. And then the theme is more of the styling. And we don't have the other 2 categories in this example. So with SMACS, it's easy to understand compared to other paradigms because there's 5 buckets and they're fairly clearly defined. And it's been proven to scale across small and big project sizes. It's been around for a while. It's been tested. The disadvantages is that compared to other paradigms, that have been around for a while. This is kind of the less adopted. So there's only a few books out there, a few resources, not as much as like object-oriented CSS. And depending on certain situations, it can also be difficult to determine what should fit in a module versus the other categories. So there's a little bit of gray area that you have to define. And if you want to learn more about SMACS, there's smacs.com. So BEM, Block Element Modifier, is another strategy that's fairly popular. The idea of separating each of your UI elements into blocks, and within each block there's an element and a modifier. So what does that really mean? So blocks are more like reusable components, and elements are more components inside the blocks. They're coupled, tightly coupled, and then the modifier would change the appearance or the state. So if we were to go through an example, this is kind of what it would look like. It's a little bit hard to really understand right away because you have these underscores and sometimes you have hyphens, which is kind of what some people, it's like a distinctly BEM thing. But here you can see we're setting the notes as kind of the block, and then the element is the header, entry, and then we have the modifier, which is the theme default. So with BEM, you can also start adding different themes and using that as the modifier, so that's a cool way to reskin certain things. So even with the last three ways of organizing your CSS, you can see how the abstraction of how it looks to a user, it makes it easier to have certain customizations for your UI. So for example, GitLab, we have a light theme, and everyone's asking us for a dark theme, but the way our current CSS doesn't allow that. But if you were to use these ways, it would be a lot easier. So with trade-offs with BEM, the modular blocks can really reduce conflicts because you're starting to reduce the cascading effect of CSS. And there is overall decreased selector specificity. So for the most part, maybe you go 3 levels deep because you have the block element modifier versus further down. And it's also known to scale for small and big projects, and it's stood the test of time. The disadvantages is that the class names get really long, and then you also have these underscore dashes, and then sometimes you mix them up, and then your code doesn't work. So there's a coding habit that has to change, but it's there, part of the language, part of the system. And if you want to learn more about BEM, it's getbem.com. So an up-and-coming approach to organizing your CSS is the idea of CSS and JS. It has different terms and different like React and all that stuff, like styled components and all that. But I'm going to generalize it a little bit and talk about the concept of putting CSS with your JavaScript in a way that it forms the concept of a component. So that is a new paradigm that within the last few years that has been up and coming. So with this, there are some trade-offs. It's really easy to find dead code because everything is more encapsulated. You can also start doing tree shaking for CSS. So if you're not familiar with tree shaking, it's the idea where if something's not needed for the page, you don't load it at all. So this is something that Webpack has really helped with front end, making sure certain JS files are not loaded onto your browser when you're not using it at all. And you can start doing that with CSS because you're starting to bundle it with your JS. Another advantage is that there's less chances of overwriting because of the cascading effect is kind of limited in scope compared to just regular CSS. But the disadvantage is that it's still very new and it's very hard to determine what the scalability challenges are as you get to a very large project that does this. And the idea of not cascading styles sounds like really cool to a lot of people because cascading is kind of hard to debug, but it's also part of the benefits of using CSS. So part of having the cascading means you have less code duplication. And if you have a limited scope of cascading styles, you could potentially lead to more duplication of your code. So that is kind of the trade-off with this approach. And there's a website there for you to look at if you want to learn more as well. So some of you might be wondering, Bootstrap recently did a rewrite for version 4. And so maybe there's some lessons we can learn from them as to how they decided to separate out their code. I mean, after all, they're a really big open source project. A lot of websites depend on them. Surely they've thought of how to organize it. So cool thing about open source is we can open it and take a look. And it looks like the way they've separated out is based on components. So you see alert.sas file, badge, and so forth. So this is very interesting because it doesn't really fully follow the patterns that we've talked about earlier. And if we go deeper into the button.sas file, this is kind of how it's set up. We have the .button class, and we have some of the different states, a bunch of mix-ins. But for the most part, it doesn't seem to follow the paradigms that we've talked about. So you might be asking, with all that in mind, what about GitLab? What have we decided to do? And with that, I wanted to take a step back and also say, with our current CSS bloat, we're also having a different initiative to kind of fix our UI inconsistencies. So for some of you guys, if you're in CSS bloat land, you might just be trying to get out of it just for the form of technical debt. For us, there's also a UI inconsistency challenge. And so GitLab actually has a UX team that's working on a design system to make sure all the buttons are supposed to be aligned a certain way. And with that, we kind of have dual goals for getting out of our CSS bloat. And so I want to keep that in perspective as to why we decided to do what we did in our approach. So with our approach, we decided to create a new project called CSS Lab. The idea of bundling on top of Bootstrap, having some custom CSS on top of Bootstrap for our specific GitLab components to fit our styling. We're really big about not trying to reinvent the wheel, trying to create something out of scratch, just from scratch, because that's the cool thing to do. So with that, it kind of made sense for us to use a similar paradigm as Bootstrap does so that we can build on top of it. It's easier for us to contribute upstream if we find problems. And it also makes it easier for other contributors that are familiar with Bootstrap to contribute to our code as well. So with that approach, the general idea that we had was to kind of create new CSS for each component on a component level, and then document it, and then replace each old component in GitLab one at a time, and kind of cycle through that through all of our components. And then the challenge with that is that GitLab also does monthly releases, so it's quite challenging to kind of go through the cycle, and so we have to think about it more iteratively, kind of how like the diagram I showed you earlier. We have to continuously ship these components each release. So that also has specific challenges because the way the CSS is written, if we change one component, let's say we change the buttons across GitLab, there's certain areas where the selectors might do weird stuff because we have 5 level deep. So that's one of the challenges we have. And other challenges that we have is that GitLab is pretty big, and we have over 500 routes and a lot of components. So those are different uphill battles that we have to face with this kind of effort. But with that in mind, the goal for CSS Lab is to kind of become a CSS framework that implements the GitLab UI. And then we also have these custom view components that kind of automatically have the CSS styling applied from GitLab. That way, other engineers or community contributors can easily import a button or import a drop-down, everything's styled, and we don't have to worry about it. That's like the best place to be. And we would want to do that for the Haml side as well, because some of our code is still in Haml. And that would make happy developers and more productive engineers. Unfortunately, we also have other challenges. We still want to deliver front-end features every month. We don't want to have the whole team just working on redoing these components, making sure they're consistent. We still want to keep shipping features so that we're continually competitive with the market. And with that, it's been challenging because the front-end team, approximately like 16% works on this component or is more dedicated to this initiative, and the rest are building these features. So that kind of puts us in a really strange position because it's already going to be a hard initiative with 500 routes. Now we're having to make these changes while part of our team is like continuing to build things. So we constantly feel like we're trying to catch up to the changes that are going on. So interestingly, we started to start brainstorming what are ways that we can start cutting the timeline and trying to maximize and utilize what we know. So one of the information that we gathered was that most of our new front-end features are written in Vue rather than non-Vue. So non-Vue would be just HAML, just straight HTML code. So with that, we said, what if we created our Vue components first? So previously, we said we'll update the CSS and then create the Vue components that adds the CSS styling automatically. But what if we kind of reverse the order so that maybe that could save us time in the grand scheme of things? So I apologize, this chart is not the prettiest, but it's a concept just to relay kind of what the proposal is. So the idea is, so previously we said we would create the CSS lab stuff, we would upgrade Bootstrap to Bootstrap 4, and then we would wrap these components, and then we have this extra bar for the top part that says we have to update any Vue components that were implemented since the start of the initiative because of these new features that are being shipped. So if we flipped it around and we decided to create Vue components first, we could actually decrease the timeline overall and not have to do duplicate work. So what we decided to do is kind of wrap each UI component using Bootstrap Vue. So Bootstrap Vue is Bootstrap implementation in Vue, so we can easily interact with that inside Vue. And then create these components so that the rest of our team can implement them and integrate them. And then when it's time to finish CSS Lab and with all these new styles that implement the design system, we can change all these styles in one file, these wrapped components. So that's the reason we wrap them rather than just saying all front-end engineers use Bootstrap Vue, because then we still have the same problem. We still have to update each instance that uses these components. And this would be the more efficient way and make us all happy. So where are we today in the process? That all sounds like the happy path. It's going to take forever. Good luck on that. And we are here today. We are in the phase of wrapping components, but we are making good progress in that. And we named this component library GitLab UI. So we've started this about 3 months ago, and we started using this tool called Storybook. So if you're not familiar with Storybook, it's a tool that lets you display your UI components on the browser. It does a lot of these documentation automatically, lets you interact with these components on the browser. So it's kind of like supercharging your development. So we decided to add this to GitLab UI so that other engineers can see what components are out there and start interacting with them, as opposed to just looking at the code and trying to figure out what this does. We added review apps for Storybook. So one of the cool features of GitLab is that we can add review apps, which means whenever you create a merge request, you can automatically deploy an environment that specifically targets that merge request. So that way, whenever I create a merge request or my team creates a merge request, as a reviewer, I can easily click View App, and it launches the browser for the Storybook. And I can interact with the component, making sure it's doing what it's supposed to do. And that really accelerates our progress and makes it easier for everyone involved. We added image snapshot. So this is some of the things that didn't even consider when we were talking about CSS bloat and how to get out of it. One of the challenges with CSS bloat and trying to get out of it is figuring out how to make sure you're not creating visual regressions, because visual regressions is a pain in the butt. You don't really notice it until it's too late. There's a lot of different ways to tackle it, but there's not a really clean way to do it. You can try to do visual regression at every page that you have, but if you change some text, then you're going to get false positives. So the cool thing with Storybook is that there's an add-on where you can start doing snapshots of the component images. So here's just an example of what it would look like if we had the loading spinner. Let's say someone made a mistake and made it 5 times as big. We have the left side what it's supposed to be, what it's checking for, and the right side is what it's generated, and then you have the diff. And so this is all outputted as part of the CI. It makes it a lot easier to figure out visual regressions on the component level, makes it more manageable and understandable. And so the way we've implemented with image snapshot with GitLab UI for the current iteration is that we're actually importing our CSS, our mega CSS bloat into our GitLab UI so that we can make sure that as we're building these components, we're not creating visual regressions. So we've actually started taking steps into ensuring that our visually on GitLab that we're being consistent, which is really cool. It's a win that we have now that we didn't even consider during this initiative. One of the cool things about Storybook, if you're not sold on it yet, is there's these cool things called knobs. So in this GIF, I am able to change kind of the props of these components on the browser and kind of start playing with the components to figure out what it can do. So we added this feature so that it creates more visibility into the components that we're using, also lets you kind of see how the styles are. So it's a big win for developer productivity.
Are you changing like properties in JavaScript when you're editing those knobs?
Yeah, so this is specifically integrated with Vue. So Vue has props where you can kind of pass in to change the values, but they also have this for React and other component libraries as well. But yeah, there was very little setup for this, and I can show you that at the end. But yeah, it's really cool because this is just the progress bar. It's like a very simple component. Everyone can usually visualize what 50% looks like. But when you get to like modals and more complicated components, that's where it really shines. Good question. So we also added README. Documentation is one of the challenges we have at GitLab, especially for front end. It's very hard to keep up with that. So we really tried to make intentionality into having one documentation, just one person has to update one file versus like all these different places. So we have it in Markdown so that it's in a Markdown file and it can be loaded into different places because our team wants to add this on the design system website as well. So we want Storybook to be kind of like the playground, the developer playground, and then the design system website would be more of the specs and actual like documentation. So this way we can kind of write the documentation once and deploy it to both sides. We also added auto-publishing to NPM, so we want NPM to kind of manage our dependency. So we use this tool called Semantic Release. Semantic Release is great because based on your commit, how you set it up, it will parse it and determine whether it should release major version, minor version, or patch version. So this is super helpful for us. And right now we've set it up to manually run as a manual CI job whenever you want to release. But I'm actually starting to think about whether we should automate this process so that whenever you push to master and whenever you merge a merge request, it automatically parses and determines whether it should just do a new release. So the trade-off there is that you might end up with like, I don't know, version 100 very fast, but people don't have to wait around for a new version to be deployed. So the challenges of this whole endeavor is that the process takes a lot of time. 500 routes is not easy, and a lot of visual regressions can pop up. And it can seem like it's not critical when it's compared to new features. And that's kind of the trade-off. I think that with getting out of CSS bloat, it can seem like a sinking ship. And sometimes you can replace parts of the ship, and sometimes you have to just have a new ship in general. And that's kind of how we're going at it. But there's a huge risk whenever you rewrite something this big, because there's always a chance that you get to a certain point and you realize you're never going to finish. The last mile is the hardest. So I think that with this endeavor, that's one of the greatest challenges we face. But with that in mind, there's a lot of great goals with what this initiative can do. It can accelerate development for the team. The idea of having engineers and contributors in the community not have to worry about styling is a really cool idea. So that's kind of what we're going for, and having that UI consistency just makes our product a whole lot better, as well as this graph that we would want to be, where the CSS would eventually taper out into the size of our CSS as we progress, because the components are already defined. We don't have to add more just because we have new pages. So that's kind of the goal. So the main takeaways I want to leave behind for you guys is that you don't always have to just pick one paradigm of organizing your CSS. You can remix them and make your own. But the most important part is that you want to be consistent with what you're doing. If you have consistency, then you can kind of scale it. It may not scale as well as certain paradigms, but it will still work. And then if you want to contribute to our discussion or track our efforts, feel free to check out that link of our GitLab UI project. We'd love for your input. If there's something better that we can be doing, that's the cool thing about open source, is that we can learn from you guys and you guys can learn from us. So everything I talked about with our last 3 months progress is in that project. So if you want to use Storybook, maybe you're using Vue, you can kind of leverage what we're doing and just even copy what we're doing. That totally works. And additional resources, if you want to learn more about CSS paradigms and making sure that you're writing maintainable CSS, here are really good talks and articles, as well as some tools to kind of gather metrics of your CSS. CSS stats is really cool for analyzing, though you also have to be careful what stats you think about, because just because you have raw stats doesn't mean it's going to help you navigate like what's important, kind of like what I mentioned earlier. You don't want to optimize. You don't want to optimize for the things that have very little gain. So that's a good tool to check out. I highly recommend it. And with that, I want to thank you for your time. And if you guys have any questions, be happy to answer it. I can also show you the project if you want. Atomic CSS, I haven't really dived into it as much. Yeah, so I don't have much to say about it. Sorry. Yeah, so right now, our CSS code is increasing as we add more features and we add more pages. And sometimes when you add more pages, you're adding more UI components, UI elements that you haven't seen before. But most of the time, you're adding things that already exist. So for example, buttons don't need to be recreated in CSS when you're adding a new page. So ideally, as your project matures and you've written your CSS well, then as you grow out, you're not writing as much CSS because most of it is already written. Most of the things are already reusable. Most of your buttons are already designed well. At that point, maybe you adding charts, might have some chart styling or something, but for the most part, you're not writing that much CSS. Does that make sense? All right, so here's the project, GitLab UI. We automatically use GitLab Pages to deploy the storybook. So here is the storybook. And so we can change like the current page. On the props, we can do the total items. So it's just really,
So it's like a pagination component.
yeah, this is a pagination component. And then the progress bar I was showing earlier. Modal is pretty nice, so we can start doing open modal and opening that, and then an open modal, and then we can start changing the header background. So it's just really nice for development. The loading icon, and then tooltips. We definitely have a lot more components. It's just the first few months of adding these components. And then the props. So the way that Storybook works is that you have your components and then you create stories that kind of talk about them, is I guess the abstraction that they're doing. So if we look at, for example, progress bar. So this is how we're doing the props. So we basically, with Storybook, is we use the add-on called knobs, and we basically have a function that says what it's called and then the default value, and then you just plug and play, and then now Storybook lets the user modify these props dynamically in the browser. So very nice. Let's see. One of the, and then for image snapshots, it's very simple as well. Let's see, it's here. Nope. Not this one. Okay, here it is. So we have a storyshots.spec.js. So to do the the image snapshot diffing, all we have to do is import init snapshots, init story shots, and that will integrate with this add-on, which launches Puppeteer. So we use Puppeteer on the background to spin up or to load up the version of Storybook, and then we have Jest running to do the actual image snapshot diffing. So it's fairly simple. For us, one of the challenges that we faced in this was, for example, the loading indicator, we want it to spin by default. But then when you're doing like an image snapshot, you don't want it to spin because then it's not deterministic in your test. So we decided to, this took a while. There wasn't really too much documented out there, but we decided to add this, this function call that's part of Puppeteer to add a style tag. So we add our own specific storyshots.css, which disables all the animation whenever we're doing these tests, because we don't want to test for animation for that kind of test. So that's something cool that we recently worked on. And another thing this past month that we did with documentation. So the way image story shot works is that it actually diffs the main view. So this whole view is getting diffed, which is very challenging when it comes to having documentation. You don't want to get your documentation diffed. And so we actually wrote an abstraction to the stories function where we actually start adding the docs only if it's not in the test environment. Because whenever we do the image story shots, we're actually generating a storybook version, and we have to be able to generate a test version and a production version, and that's how we determine when to render the docs or not. Cool. Any other questions? Like, have we kind of deviated from Bootstrap's UI? Yes, we have, but it's hard to think of anything off the top of my head. Yeah. But there's more like sophisticated. So ideally, we want to have our storybook have these like basic building blocks for the components, but then eventually it would be nice to have like, let's say, the sidebar as one component. So start building more complex components that you can start interacting in Storybook that you would have never even dreamed of before this whole process. Cool. All right. Thank you, everybody, for your time.